For the first several years of large language model development, a simple rule applied. The bigger the model and the more compute, the better the results. Teams could almost linearly improve quality simply by adding more GPUs and more parameters. In 2020, OpenAI described this as the so-called scaling laws, according to which increasing compute reduced model error in a predictable way and improved performance across language tasks. This mechanism worked until around 2022. That was when models at the scale of GPT-4 and beyond appeared, exceeding 10 to the power of 25 computational operations. This marked a transition into a completely different infrastructure and cost regime. And that is exactly when the curve began to bend. DeepMind, Epic AI, and Stanford show that beyond this threshold, each tenfold increase in compute delivers only minimal improvement. Error drops on the order of one or a few thousandths. In other words, you have to spend 10 times more resources to get an almost imperceptible gain in quality. Costs grow exponentially while performance nearly stands still. This is also visible in benchmarks. GPT-4 reached about 86% on MMLU. Newer, many times larger models reach around 90 to 92%. This is an improvement, but it is not a breakthrough. It is just polishing the same curve. Scaling has stopped being the engine of progress. It has become a very expensive way of squeezing out the last few percent. The problem is that even these small benchmark gains increasingly do not represent real progress. Instead of measuring reasoning ability, benchmarks have begun to measure how well a model has learned specific tests. Stanford's CRFM, OpenAI, and LMSYS have shown that popular datasets such as MMLU, Human Evil, and GSM-8K are heavily contaminated by training data. Models have seen the questions, the answers, or their paraphrases during training, which artificially inflates their scores. In the case of Human Evil, OpenAI admitted that about 25% of the dataset was present in GPT-4's training data. In MMLU and GSM-8K, contamination ranges from several percent to several dozen percent, especially after 2023, when these benchmarks began circulating widely across public and semi-public datasets. When this leaked data is removed and models are tested on clean sets, performance drops dramatically. MMLU falls from about 86% to the low 70s. Human Evil drops from 85 to around the mid-60s. This shows that leaderboards increasingly measure test memorization rather than genuine intelligence or generalization. The second hard limit to scaling is data. For years, models were trained on the entire public internet, but this resource is neither infinite nor uniformly valuable. Epoch AI estimates that the total stock of high-quality human-written text is about 300 trillion tokens after accounting for quality and deduplication. Meta admits that the best sources alone, books, Wikipedia, and GitHub, amount to only a few trillion tokens. Everything else is increasingly diluted, repetitive, and low-quality web data. GPT-4 used about 13 trillion tokens. Llama 3 used around 15. At the current pace of training new generations, the data wall appears between 2026 and 2032. The larger the models get, the faster they consume the available high-quality text. To keep scaling, companies increasingly rely on synthetic data, text generated by other models. This closes a feedback loop of errors and gradually degrades quality. Without new human-generated data, simply making models bigger stops producing meaningful gains. Scaling does reduce hallucinations, but only up to a point. The larger the model, the more data it has seen, and the better it becomes at basic factual consistency. On Truthful QA, GPT-2 hallucinated in more than 70% of its answers. GPT-3 dropped to around the mid-40s, and GPT-4 to below 30. Stanford, Helm, and Anthropic show a similar trend in their evaluations. However, newer reasoning-oriented models such as O3 and O4 Mini sometimes perform worse because they aggressively guess answers instead of admitting uncertainty. OpenAI reports cases where hallucination rates reach even 40% on difficult questions. This shows that scale alone does not solve the truth problem. Size helps, but data quality and training methods matter far more than the number of parameters. In the end, economics and architecture set the real limits of scaling. GPT-3 costs several $1 million, GPT-4 over 100 million, Llama 3 around 1 to 200 million, DeepSeek, counting full infrastructure and data costs, exceeded 1 billion. Each new generation moves into an entirely different budget category, and that is just training. Inference, the day-to-day use of a model, adds additional costs per millions of tokens. For models above 100 billion parameters, those costs grow exponentially because of memory and GPU requirements. On top of that comes transformer architecture, where attention cost grows with the square of context length. With millions of tokens, hundreds of gigabytes of memory are required, making further scaling increasingly impractical. That is why the industry is turning to distillation, MOE, and quantization. Not because they are fashionable, but because brute force scaling has stopped being economically viable. Thanks for watching. If this was useful, consider subscribing for more technical, no-hype analysis of AI and technology.